So here we have the 2016, this is paper 1, question 5, junior cert higher level, and it shows the graph below shows the distance on a track travelled by Anne over the course of a race. The graph is in two sections labelled A and B, and we are asked to show that Anne's speed in section A is 5 meters per second. So if I want to find her speed, well, the distance is on this side and the time is on this side. So the distance over the time, which is also the slope of the graph, is going to equal to the speed. So if I say get the slope, say from, say if I go the rise to here over the run, which is 60, so 300 over 60, and then I get 5 meters per second. So that's her speed in the first section of the race. But say if I want to get her speed in the second section of the race, well, this speed is different, so I'm going to have to get the rise just in section B, and then the run just in section B. So the rise in section B is going to be from 300 to 400, so the rise is going to be 100, and then the run is going to be 60 to 100, so it's going to be 40. So then we have 100 divided by 40, and we get 2.5 meters per second. So that's her speed in the second part of the race. And now I was asked, so now I'm given a good few graphs, and I'm asked table 1 shows the graph of the distance travelled along the track by Bill, Claire and Dee during the same race. Each person's name is written next to their graph. Table 2 shows the speed of Bill, Claire and Dee during the race. Complete table 2 by writing in the correct name. Well, say if we just look at this graph, well, distance over time is the speed. So if the graph is steeper, it's going to have a higher speed because the slope is going to be greater, because the slope is the speed. So I'm going to go with this one first. If I look at this one, the distance over the time, the slope of the graph is the same all the time, but the slope is the speed. So the speed is going to have to be the exact same at all times. So it's going to be this one. This is Claire. If I look at this one, well, the speed started off, it's after getting faster because the slope is after increasing. So if I look at one that the speed is after going up, well, it's going to be this one. So this is Bill. And then if I look at this one, well, the speed is okay, but then it's after decreasing and decreasing. The slope is after getting a lot less. So then this one must be D, the final one. So then I'm asked, the graph below shows the distance Eric travelled along the track during the same race. Sketch the graph of Eric's speed during the race. Well, say if, so don't mind that for a second. So say his distance here, he's going, but then here his distance isn't changing as time goes on. So in this section, he's not moving because his distance is not changing as time goes on, so he's not moving. So then we come up, he moves again. So if I was to look at his speed versus time, well, in this section from here to here, he's not moving, so the speed is going to have to be on 0. So then he's moving here, so up here, and then he's moving at the end. So it's like this. So that's going to be the graph of speed versus time for Eric. And then and that is the end of that question. Thank you.